Oh, no way. Oh, that's a lifesaver. That's a lifesaver. Yo, look at the fidelity on this. This looks so great. Uh-oh. Look at that. Oh, this is amazing. Oh, I love it. Live, laugh, love it. All right, let's see if we can frame this out just a little bit better. I mean, it's probably as good as we're gonna get, huh? Bring it up just a little bit. It's about as good as we're gonna get, yeah. Do 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 do. A skeleton do. I guess we just zoom in like so, huh? Mm, mm. Bum bum bum. Do, do. Oh, look at that! Holy smokes! That's beautiful. Man, I'm really chuffed. Oh my goodness. What does Darkfield look like? Oh, wow. Yo, this is so much better. Holy crap. I love this. What organisms are we looking at? Good question, NH2W. There's a whole bunch of them. This one in the center is Frontonia. The larger kind of, I don't know, cucumber-looking one. These thinner ones that are shaped like slippers or grains of rice are called Paramecium caudatum. These are all single-celled organisms. None of these are like bacteria. They don't make us sick, so to speak. The small little mushroom-looking ones are Eurocentrum turbo. Again, another single-celled ciliate. These long ones here are also single-celled ciliates called Spirostomum. All these pretty much eat bacteria, and they graze upon these thin strands of cyanobacteria down there. Great question. Great question. I'll mute myself too. It's pretty cool. What else can I do? Welcome in, everybody. Hello. Welcome in. Just thought I'd see what's up with YouTube. It's actually great streaming quality. This is much better than the other places I've been at. Beautiful Spirostomum here. Long single-celled organism. All those food bits in it too. So those, so beautiful. So beautiful. There's a euplotes down there. Euplotes. That one. We can, I mean, we're not even close to zoomed in all the way either. What is that? That's a little ostracod. Little microcrustacean. I'm gonna check this one out quick though. Oh, heck yes. Nice. And see the little cilia, the tiny little hairs that they have? See, it's kind of like waving on the edges of it. Yeah, that's, those are called cilia. And all these organisms have those cilia. Beautiful. I'm gonna change the lighting up. Everybody cover your eyes. Cover your eyes, flash warning. What are the strands, though? Strands of bacteria. Most likely a cyanobacteria. Most likely. Yeah, just individual strands, or individual cells making up these long, long strands. I'm trying to get a good zoom in on it. I thought it was just random matter. Oh, no, it's alive. It's super alive. You can see how it kind of all wiggles and moves. Here, zoom in one more time. All right, come on. You need to get the fuzz out of there. It's a normal reaction, NH. Valid reaction. They're made up of individual little cells all linked together. Right? It's pretty cool. Excuse me. My apologies. All right. But yeah. Sorry about the lineup of the camera, too. I'm still working on trying to get this mount to be as perfect as it can. It was a vert, so I just need to keep it. All right, let's see if I can do that. One sec. Bam. All right, that didn't do anything. That did nothing for you. That did literally nothing, but it's just going to have to do. What's this sampled from? A freshwater pond. But I know what I'm looking for, and I know how to culture samples, so these doesn't necessarily represent the density that you'd find in nature, but it's just freshwater pond. They're near the shore with some soil, some aquatic vegetation in it. And by aquatic vegetation, I mean like decomposing leaves. So it normally fuels the cyanobacteria. Well, not the cyanobacteria, but the bacteria, and the bacteria is a food source, right? Bacteria start to eat the leaf, they reproduce, make lots of themselves, and you got lots of food if you're one of these things, one of these parameciums, or any number of these organisms that we see at this level. But yeah, just a freshwater pond. It's really tough, too, as a microscopist, because a lot of content comes out on all different types of apps, and a lot of it's not genuine. Just put it that way. Yeah. I'm gonna change the lighting again, just to see how it looks. Cover your eyes, flash warning, flash warning, flash warning. Bring it down. Cool. I like that too. That's nice. You think drinking this could be dangerous? Yeah. Not these things that we see swimming around. It's the things that we can't see. The virions, so the virus particles, and then also the bacteria, right? And that cyanobacteria, that filamentous, the hair-like stuff, nah, it's probably not going to be good for you. I don't know what would happen to you. I'm not a doctor, but we can make the strong assumption that drinking pond water is bad, right? Uh-oh, we're getting a little bit of lag going on here, it seems. It's too much for you, YouTube. You can't handle it. You'll test it yourself. You're gonna have a sippy. NH. You're gonna have a little sippy. Okay. You let me know how that goes. But don't do it. That's my recommendation to you. Here's the Frontonia. Frontonia. And right over here is a Euplotes. I love these Frontonias. Just wonder what the filament things eat. They're photosynthetic. You can see they're like a little orangish, yellowish. So there's pigmentation in there similar to chlorophyll. The photosynthetic, they don't need to eat anything, so to speak. Right. Which is cool. Yeah. Yeah, they're photosynthetic. So they rely on the same things that basically the same thing that plants do, to be honest. What about the longworm? Spirostomum. Spirostomum. Not actually a worm. It's a protozoan, a single-celled ciliate, so it's a eukaryotic. This thing is one cell, just one really gigantically big cell. You can see these without a microscope. They're pretty large. I mean, they're not large. You need a good backlight, but you can see them. So if you shine a light from like behind it or on the side, you'll see these in a sample jar, but not just floating around in the water. And this right here is an actual worm. This is an Eliosoma. Do they other protozoans? No. No, none of these things really eat each other. These are more grazers. That worm down there is an actual annelid worm called Eliosoma, Aeolosoma. I know it's the spelling all right. But yeah, these have little oil droplets where all the red comes from. All the little dots down there, how polka dots, those are oil stores. And this probably like helps them sense where they are, maybe orientate themselves. Beautiful organism, though. Normally, again, these things are going to be eating bacteria and detritus. And the protozoans normally don't have the capacity to even harm each other, NH, because they don't have like the teeth, they don't have mouths, they don't have claws, they don't got anything like that that would allow them to predate on each other. All these things are mostly eating bacteria. As you see the Frontonia will sometimes eat another ciliate, but normally they're eating little pieces of algae or long strands of cyanobacteria, like this stuff. Right, because you'll see sometimes they get these long filaments wrapped up in their inside of their cell. Yeah, that's food bits in there, unfortunately. The nucleus is much smaller than that. Normally, you can't even see a nucleus without like pulling it out and then using some like nerd staining lab technique. You can see macronuclei in some organisms, which is just another nerd thing, to be honest. Good questions, though, NH. Good questions. Got to, it's 3D, but it looks like it's 2D. Yeah, no, and that's super because, like, definitely because of our perspective, right? We are literally looking as top down as you can top down anything, right? We're looking directly above the sample, and the only way that my brain tells me if things are closer to me or if they're further from me is if they're in or out of focus. Let's try to find something here. Like, you see that one down there? It's kind of out of focus compared to the rest of them. But let's say I zoom out, they get out of focus. They're all pretty much on the same plane right now. This is some pretty easy microscoping right now, just going to be honest with you. There's like a strand of paper towel because that's what I use to clean up. Yeah, it's paper towel right there. It's a whole bunch of strands of whatever makes up the paper towel. Pretty common for me. But yeah, no, it's pretty interesting because it is hard to discern whether they are in a 3D environment or not. There's some Eurocentrum turbos. See those three down there all grouped together? They normally group together like this and bounce around off of each other the whole time, which I think is pretty cool. They also eat bacteria, and they can be eaten by like the Frontonia or the Eliosoma, but it's not very common. What's that? That's a tiny paramecium right there. Looks like it. Not doing so hot because it's so small, but it'll figure stuff out. There's looks to be a gastrotrick down there. You see that thing? It's a multicellular microorganism. It's an animal. It's an actual animal. Gastrotrick. Gastrotrich. Gastrotrick. I love this. This quality compared to the other places that I was streaming today. It's moving quite fast. Yes, indeed. They do move fast, and it's pretty small. Yes, it's funny to think that thing is multicellular, whereas all the other things that we're pretty much seeing, like things swimming around, those are single cells. And it's just kind of cool. I've always thought it was kind of cool that multicellularity does not equal size. And these only live for like 2-3 days too. Reproduce by like their second day of life, if not sooner. Yeah, they reproduce rather quickly, and they lay eggs too, which is wild to think about. Something that small makes an egg. Look at the cilia here. Oh wow, the cilia quality is so good on this app. Holy smokes! Whoops, YouTube. I think this might be where I end up like, if the app goes away, it's probably where I'm. Is there a Eurocentrum Turbo in there? There is. Where'd he go? Yeah. Oh, it just came out, I think. Dang it. That was so cool. I'm just kind of upset I didn't catch the whole... Wait, no, it's right there. Look. There's a Eurocentrum Turbo. What in the world? There is another organ. See, like, you see how I said those Eurocentrum Turbos can maybe get eaten? It's just stuck in there. I wonder if it will digest it. That's so cool. Oh, I definitely need to save this footage. Definitely need to save this footage right here. This is interesting. Yeah, there's another organism just right inside there. I think it's too small or too large for it to digest it, but we'll see. I mean, that's wild. Whoa. That's so cool. Whoops, sorry. Whoa, look at that. Reminds me of a washing machine. It does. It really does. Look at this. A Eurocentrum. That's so cool. I'm so happy I saw this. This is incredible. Yeah, more or less, NH. More or less. That's so beautiful. Again, that's another organism, a Eurocentrum turbo, that somehow ended up in the mouth of the euplotes. And it's, I don't think you can swallow something that large. So I don't think that's good for either organism, to be honest. I don't see how this relationship would benefit either one of them. But the Eurocentrum turbo seems to be slowing down a little bit. Whoa, so yeah, we gotta watch this now. I wasn't planning on going that long, but I want to see how this ends. Again, because if we see the Eurocentrum turbo stop moving, which it's slowing down. It is slowing it down. Huh. Whoa. No way. I think it's digesting it. Yes, it is. Holy smokes. Yo. Yeah, it is. It's just been mushed up. Yep, it's gone. It is in there. Whoa. I know, I shouldn't be so excited about this. But I was unaware that euplotes ate Eurocentrum turbo. I was super unaware of that. I've never seen that. I'm just thinking, if I didn't go live just for giggles, I wouldn't have got to see that. I wouldn't have. It didn't just swim out. No, it didn't. It's still in there. Okay. That was cool to see. Y'all, that was awesome. I mean, sad, but awesome. And the fact that was novel. Again, I've never seen anything quite like that. Never seen anything quite like that. That was so cool. I'm nerding out so hard. What are the spiky things behind it? So those are like just enlarged cilia, more used for probably locomotion and sensory input. They're not, they do look kind of spiky and mean, but they're more like floppy little noodles, to be honest. But they're probably used for like sensory input as well as like securing them. I want this cough to go away. Securing themselves in the detritus by like kind of like hooking on a little bit, increasing their surface area, or the scientific word gription. Gription's not a scientific word, but whatever. Well, there's a stenostomum. That's a stenostomum, a type of flatworm. Yo, look at it. It's churning it up. Churn it up. Churn it up. That's so cool. That made me relatively happy seeing that, even though it's sad. But let's move on because we ground to mush. Yes. So what happened is it probably got digested by enzymes. So let's see if the stenostomum does. No, don't go up there. I can't go up that far. Stop it. Stop it. Ugh. Whatever. Whatever. See, I can't go up any further. Just kind of how I have the slide set up. It's my bad. Oh my goodness, that was cool. Oh, I'm such a happy boy. Just drop a soap and see what happens. Yeah, I don't think I'm gonna do that. The fact is, for me, and I understand your question, your curiosity, but we know what would happen. We know what soap does and what antibacterial stuff does and how it can affect the cellular process. But if I were to take them from nature and capitalize on them, which I'm already doing, let's be totally honest and frank with ourselves. But if I were to take it a step further and then destroy them just for internet clout, I feel like a tree would fall on me. I'd get struck by lightning, and rightfully so, right? I feel like then that's a little far, just taking nature to destroy it just for internet clout. I mean, people have done much worse, and I'm sure people really wouldn't care, but I do. So I ain't gonna hurt them. Sorry, NH. Here's the reason why. It's like, people like love puppies and cats and stuff like that. I mean, I love puppies and cats and kittens and whatever, too. But like, I love microorganisms like puppies and cats and kittens. So it would literally be like me. Like, I can't even fathom it type stuff. But I get your question. I could tell you what would happen, depending on what you put in there. Like, if you put the one with like a isopropyl alcohol in it, it would eventually kind of get confused. It's more personal. We can actually see the things. Yeah, I mean, they've been a part of. They've been like, people have like those getaways. Like that thing that you can just go to and it's always like familiar. That's what this is for me. And it's not familiar, but it's just normal. But I could tell you what would happen. Like, let's say you put isopropyl alcohol in here. Like the rubbing alcohol. You put that into this sample. They get confused. Like they would literally for a few minutes look like they were drunk, right? They would kind of. You would tell their behavior was confused. They wouldn't know where to go, and that would just be the intracellular processes being like impacted by the isopropyl alcohol. And then after a little bit, they'd stop moving for the most part, just kind of hang out there for a second, and eventually, bam, they would just lyse. Lysis is there's many types of different lysis, but it's basically where the cell membrane ruptures, all the contents of the cell are expelled. It's just a breakdown in an osmosis, more or less. For antibacterial stuff, I mean, I don't know how that works. I'm not a doctor, and antibiotics are really not my forte, but I know that certain antibiotics impact certain processes of bacteria. Would they do the same to these protozoans? Probably, I would imagine. It may have some impact on them, but I don't know. And if you put things like bleach, I mean, it would be pretty much instantaneous. Depending on like how much of the bleach was in the water at the time. I mean, bleach is super toxic to everything and everywhere. So it'd pretty much be instantaneous with that. You would see just pretty quick like cell lysine breaking apart, right? But if you want to know what the best thing to do to clean your countertops with is, and this is what they use in laboratories, right, is isopropyl 70%. The reason you use 70% is because you want the water content in there so the isopropyl does not evaporate. Because if you use like 90%, it evaporates rather quickly. And that's not so good when you want to make sure that it's getting rid of all the germs, because if it all evaporates and doesn't get all the bacteria. 70% isopropyl. But then again, that could probably be harsh on some countertops, I imagine. Is there a way where I can just make the chat all messages are visible? Yes. Okay. That's it. Wait, can you all see that then? Oh no, I don't want that. I hope you can't see them. Welcome to live chat. Remember to guide your privacy and abide by our community guidelines. You got it, YouTube. Love you. See? Me and YouTube are already getting along, everyone. Already getting along. Like two doves in a pea pod. That's right. That's the saying. Okay. Well, what happened? What did I do? I was just reading. Are you were just imagining like what the best to clean? Oh, yeah. I've always thought isopropyl alcohol 70% is good enough. And then it's just like the least amount of toxic for yourself, your pets, and your family. You're welcome, NH2. Have a good night. Get your homework done. You better do it. I'm not going to be going too much longer anyway. Probably about another 4 minutes, and I'm going to wrap this hot dog up over here. I got to squeeze me some moss. That's a normal thing. Music by Bad at Math Lo-Fi, and it's Bad at Math Lo-Fi. It's a good friend of mine. I just ask that you check out Bad at Math at Lo-Fi, because he says I can use his musicals. And boy golly, does that make me happy. Ooh, that's an odd looking bubble. Okay. Bum ba-da-dum. Bum bum ba-da-dum. Bum bum ba-da-dum. Bum tap 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 Let's go for another minute and 30. Mike, come on, put it together. Get it together. All right, let's wrap this one up. Bye, everyone.